Hello guys, it's me, Torino Kylie. I'm going to discuss about naming an element of ionic compound. First of all, what is ionic compound? Ionic compound is a chemical compound composed of ions held together by electrostatic force termed ionic bonding. The compound is neutral overall but consists of positively charged ions called cations and negatively charged ions called anions. But in naming compounds, the ionic compounds are named by stating cation first, followed by the anion. Positive and negative charges must balance. Some anions have multiple forms and are named accordingly with the use of Roman numerals in parentheses. An ionic compound consists one metals and one non-metals.
When writing the ionic compound, you should know the first charges. So let's take a look in periodic table. You can see it has category which are the metal, non-metal, and transition metals. But in transition metals, we can see there is no charges indicated. It is because the charge of it may vary. It depends on how it bonds. Let's take for example the iron, where can have a plus 2 charge or plus 3 charge. Another example of transition metals, and let's write its formula, the manganese 4 oxide. Let's write the symbol and charge. Take note, we know this is transition metal because we have the Roman number in here. The symbol for manganese is Mn with plus 4 charge and oxide with symbol O. And we will look at periodic table again. Oxygen is in minus 2 charge. So, let's balance to get the formula. To balance, this put a subscript 2 in oxide, then multiple to the charge of oxide, which is minus 2, that give us the answers of negative 4. So, we can cancel now the charges and that make the formula of manganese 4 oxide into MnO02.
There are three types of ionic compound. First, ionic compound without transitional metal. Let's take, for example, aluminum oxide. Aluminum show as our metal and oxide as our non-metal, ending in De. Note, for ionic compound, we will always have to balance charges. Aluminum has positive 3 charges and oxide has negative 2. After that, let's do lasso or cross multiply and we'll get Al 6 positive 2 and 6 negative 3. Then eliminate 6 positive and 6 negative. So ionic compound name is Al2O3. The second is ionic compound with transition metal. This consists of the name of our transitional metal Roman numeral in parentheses and non-metal ending in IDE. The third one is the ionic compound with polyatomic. It is consists of name of our metal and our polyatomic atom. But first, let's discuss the meaning of polyatomic atoms. Polyatomic atoms just mean that there are 2 or more elements within that atom. Ionic compound with polyatomic atoms end in ATE or 8 or items, but except for hydroxide and cyanide. So we have an example, calcium or Ca2 positive as our metal and phosphate, 3 negative as our type of polyatomic atoms, calcium phosphate. So calcium has 2 positive charges, phosphate 3 negative. So to balance charges, we need to place this in parentheses to isolate the phosphate group. So the given now is calcium equals Ca2 positive and phosphate is equal to open parenthesis PO4 close parenthesis over 3 negative, then do lasso. Then the ionic name is Ca3 open close parenthesis P042.
So good day, ma'am. I, Arlisa Cablos, a presenter of Group 4. So I am here today to talk to you about the covalent bond. So how are we going to define the covalent bonds, by the way? How are they made and how do they form? So it's simply the bond formed between atoms by the sharing of electrons. So first, only the noble gases exist naturally a single atom. All the other elements of the periodic table have partially filled valence shell or outer electron shells. Atoms bond by swapping or sharing electrons in their outer shells. When very different atoms react like metals and nonmetals, they normally swap electrons, and this is what we call ionic bonding. But when similar atoms react like nonmetals combining with other nonmetals, they are share electrons, and this is what we call the covalent bonding. Nonmetals elements are found on the right-hand side and in the upper part of the periodic table. Some common nonmetals are carbon, nitrogen, oxygen, and the halides. They have shell of electrons that are normally half or more than half full of electrons. And since they have a strong attraction for a few additional electrons, it is strongly energetic and favorable for them. So they share electrons by overlapping orbitals. These make an bonding orbitals or covalent bonds that contains two electrons. So looking, covalent bonds are directional, which means they are in a fixed position like holding hands. This is too different from ionic bond, which form with an electrostatic attraction between charge of ions. Overlap between orbitals means that the atoms in the covalent bonds are very close. So these things make covalent bonds strong. There are two kinds of covalent structures, small molecules like water and giant compounds like diamond. There's a little attraction between molecules and forces between molecules are weak. Compounds made from small covalent molecules has low melting and boiling points and volatile, and they do not also conduct electricity.
Good afternoon, ma'am. Good afternoon, classmate. My name is Kim Sandaratia and I will discuss to you the example of covalent compound. You can recognize covalent compound because they only consist of nonmetals. Alternatively, consult a table of electronegativity values of the electronegativity values of the elements in a compound are identical or similar. Then they form covalent compounds. As a general rule, if the electronegativity difference is less than 2 on a Pauling scale, the atoms form covalent bonds. If the electronegativity difference is 2 or more, the electronegativity form ionic bonds.
Good day everyone, I am Christine Joyu Fabian. Let me introduce you some examples of covalent compounds, which is the hydrogen chloride, methane, water, and the oxygen. I will discuss first the hydrogen chloride. The compound hydrogen chloride has the chemical formula HCl. It has a gas at room temperature and pressure. A solution of the gas in water is called hydrochloric acid. Hydrogen chloride is commonly prepared both on a laboratory and an industrial scale by the reaction of the chloride, generally that's sodium and with sulfuric acid. It is also produced by the reaction of the some chlorides with water and as a byproduct of the chlorination of many organic substances. Secondly is the methane. Methane is a chemical compound with the chemical formula CH4. It is a group 14 hydride, simply as alkane, and the main constituent of natural gases. Methane is the simplest member of the ferropene series of hydrocarbons and it's among the most potent of the greenhouse gases. It is lighter than air, having a specific gravity of 0.554. It is only slightly soluble in water. It burns readily in air, forming carbon dioxide and water vapor. The flame is pale, slightly luminous, and very hot. Methane in general is very stable, but mixture of methane and air with the methane content between 5 and 14% by volume are explosive. Explosion of such mixtures have been frequent in coral mines and collieries and have been the cause of many mines disasters.